The radian is a measurement of an angle that is more useful than degrees. This is defined by the angle subtended at the centre of a circle by an arc length equal to the radius. If we draw a circle with a radius r and create a sector with an arc length of r, the angle will be 1 radian. 1 radian is roughly 57 degrees.
Is useful as a full circle is 2 pi radians. 45 degrees is pi by 4 radians. 90 degrees is pi by 2 radians. 180 degrees is pi radians.
Converting to radians from degrees can be calculated by pi over 360 times the angle in degrees.
Using the speed equation v equals x over t, we can substitute in the equation for the circumference of a circle, x equals 2 pi r, and replace it for the x in the speed equation, giving us v equals 2 pi r over t. In f equals ma to f equals mv squared over r, we can derive the equation a equals v squared over r. This is what we call the centripetal acceleration. By Newton's law, if there is a centripetal acceleration, there must be a centripetal force also acting towards the centre of the circle.
A centripetal force arises when there is a net force acting towards the centre of a circular path. At the bottom of the loop, the contact force provides the net force towards the centre, where the weight opposes it. However, at the top of the loop, both the weight and contact force provide the centripetal force. Here, the contact force is smaller than the contact force at the bottom of the loop.
Newton's law of gravitation. Any two masses will attract each other with a force proportional to their masses, and inversely proportional to their distance. The relation is F equals gmm over r squared, where big M and small m are the two masses. R is the separation from their centre of masses, and g is known as the gravitational constant, 6.67 times 10 to the minus 11 Newton meters squared, kilogram to the minus 2.
We show any masses having radial gravitational field lines. Depending on how close the lines are together shows the strength of the field. The gravitational field strength on Earth is the familiar 9.81 newtons per kilogram.
However, close to the Earth's surface we consider the lines to be parallel and equidistant. This has to be shown on diagrams. In a uniform gravitational field, G equals force per unit mass.
Because the centripetal force and the motion of the planet are perpendicular to each other, no work is done. The orbital speed of an object can be calculated by v equals the square root of gm over r. V being the speed, g being the gravitational constant, m being the mass of the planet, and r being the separation. A geostationary orbit is a particular orbit a satellite can have. It is an equatorial orbit with an orbital period of 1 day. The satellite appears to be fixed above a position on the Earth.
Kepler's third law. To derive it, we need 3 equations. We need F equals mv squared over r for circular motion, F equals gmm over r squared for universal gravitational law, and v equals 2 pi r over t. If we equate mv squared over r with gmm over r squared, we find that the small m cancels along with 1r, leaving us with v squared equals gm over r. Substituting in v, we get 4 pi squared r squared over t squared equals gm over r. And with some rearranging, we get Kepler's third law, which is 4 pi squared over gm times r cubed equals t squared.